Little chunks here where we have a real number like 2 plus 5i. This guy's called a complex number. We're going to multiply it by another complex number, which is a number and an imaginary number. So this is 2 complex numbers that we're going to multiply together. Treat it just like you would if that said 2 plus 5x and 3 minus 4x. And if you need to, switch the I out for x for a minute. Straight up multiply these together just like we do if they were binomial expressions. You can box, you can distribute, whatever we need. I'm going to do distribution, but that means I am going to color over this little title real quick just so I can use that space. So I'm going to do it with distribution. You do however you like. But we're going to take our 2 times 3. 2 times 3 gives us 6. Then we're going to have our 2 times minus 4i. We're going to get minus 8i. We're going to take our 5i times 3, 15i. And then we have our 5i times minus 4i. And what do we get here? Negative 20i squared. Okay? 100% not different than any of our polynomial stuff. But we can simplify this. We can simplify this a lot because we have some like terms here, right? So I can combine together my 6, and we're going to have minus 8i plus 15i, 7i. Also, we talked about this a bunch yesterday. What do we know about I squared? We have I squared. That's the exact same thing as having negative 1. Remember, I is square root of negative 1. So the square root of negative 1 squared gives us negative 1. So we actually have more that we can simplify because we have minus 20 times negative 1. So we're going to have our 6 plus 7i plus 20. So our final answer here is going to be 26 plus 7i. When we multiply 2 complex numbers together, we should get another complex number. We should not have any exponents on i's when we're all the way done. Bless you. Okay. The one on the right is 100% the same vibe. We're going to multiply, simplify, combine our like terms. Again, I'll do the whole thing with the full colors so you can see the whole kit and caboodle. We're going to have our minus 8 times our minus 1, giving us a positive 8. Our minus 8 times our 2i, minus 16i. I times minus 1 gives us a minus I. And our I times 2i, that's not the different color, there we go, gives us a plus 2i squared. And as we start to do these, we may start to notice patterns and be able to skip a line or two, write things down, totally valid. If you can combine these two together at the same time, totally fine. If we can switch the I squared to be our negative 1 at the same time, totally fine. I'm just writing everything down so it's, easy to track in case we look at this later and go, what? So we're going to have our 8 and our minus 17i. And we know that our I squared is really a negative 1, so this is the same thing as having a minus 2. So what's our final answer on this one? Boom shakalaka. Told you they didn't suck that bad. No saying. No saying. I've got 2 more. We're just going to combine together a little bit of our multiplying and some of our order of operations stuff. Oh my gosh. Because we did adding and subtracting with them yesterday. So this is going to mix a little bit of some multiplying, some squaring, all that jazz. But these are the last 2. Okay. Okay. So on this left one, what's our first step going to be? Distribute. Let's distribute this 3 for sure. So we're going to have 3 times 2 giving us 6 minus 3 times 5i, which is going to give us a 15i. And then I'm actually also going to distribute this minus sign through just so I don't have to deal with subtraction, because that'll make this be a plus 7 and a minus 3i. That lets me get rid of all of my parentheses. Be really, really careful when we are distributing this minus sign through. I have a lot of people that accidentally turn this into then multiplication. Don't do that. Just because we lose the minus sign doesn't mean it's not still adding. So combining our like terms together here, we've got a 6 and a 7 giving us 13. And we've got our minus 15i and our minus 3i minus 18i. Boop. On this one, we have lots of options on the order we can go through. I do recommend dealing with the exponent first, and whether you do that by squaring it individually, or if you take this and write it out as I times our 4 minus 3i times 4 minus 3i. Remember, this is not 16 minus 9i squared. I highly recommend writing it out like this just because it is easier to keep track of it. If you want to multiply in this I first and then to do this multiplication, totally fine. I have a tendency to do the exponent first and take this square. So I'm going to multiply these two guys and then distribute the I through. But you can do it in whatever order you want. So I'm going to do this multiplication first, because I'm just letting this I kind of park outside. When I do that, I'm going to have my 4 times 4 giving me 16. I have my 4 times minus 3i giving us a minus 12i. And then we have another minus 12i. And then we have a plus 9i squared. So that's that whole set of multiplication of those two binomial pieces. Complex numbers, technically, but they feel like binomials. And we can simplify that. Like, we've got a lot of pieces in here, we know. We've got our 16. I can combine together my minus 12i and my minus 12i to get a minus 24. And then this is going to be a minus 9. Oh, 24i. Can't lose my I. My eye! Don't lose the eye. Because now I have I times 16 minus 9. It's going to give us a 7 minus 24i. And again, this is not the only pathway through this. This is probably just one of the more common pathways I see. I'm just going to scooch things up just a smidge. So I'm almost at the end, but I'm at the bottom of my page. Because we only have one step left to go, is to multiply through with that I. So we're going to have our 7i minus 24i squared, but I have another power on an I. So what is our answer going to be on this? 7i plus 24, or 24 plus 7i. Again, as I say, kind of tradition is to have the real number in the front, imaginary in the back. If you put 7i plus 24, I would 100% take it. 100% totally fine. It's just kind of best math grammar is to put 24 plus 7i with the real number in the front and the imaginary back. Aside from that, it's not a big deal. When we're looking at these operations on our complex numbers, we should always wind up with a complex number or a real number or an imaginary number. So we might lose the real number part, we might lose the imaginary number part. We can have any number of pieces, but we should never have any exponents on our i's when we're done. Okay? We will keep talking about complex numbers and doing things with them because we have added, we subtracted, and we've multiplied. I wonder what we're going to do next week. But I'm going to put this up here. We're going to, on Monday, talk about dividing. and all that jazz. It's my birthday today. Yeah. We are in the random 3 months where me and my husband are the same age. Because I am 39 today, and he turns 40 in December. And I'm going, wah-ha, ha 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 ha.